as a mechanical wave propagates in a medium, the energy of the wave dissipates gradually. This will gradually decrease the speed of wavelength, decrease the amplitude of wavelength, decrease the frequency of wavelength, decrease the wavelength of the wave, increase the wavelength of the wave. We know that the energy of a mechanical wave is depending on amplitude. Energy is depending on amplitude. Therefore, when the energy of the wave is gradually decreasing, amplitude is decreasing. Therefore, we can get the answer, decrease the amplitude of the wave. Answer is 2 for an earthquake which occurs at a certain location generates a transverse wave, S wave, and longitude wave, P wave. Both waves travel through the earth, and the P wave arrives 3 minutes before S wave at a certain point on the earth. The average speed of S and P waves between the point and location of the earthquake are 4 kilometers per second and 8 kilometers per second. How far away from the point did the earthquake occur? We can use S equals ut for the transverse wave and longitude wave. I will consider S wave. Distance is x, we have to find it. We can consider, they have given that velocity of S wave is 4 meters per second, 4 kilometers per second. Time, I will get the time as t. Then we can get x equals 40. It is the first equation. Then we can use same equation for the P wave. There is the same distance. Then distance is x, velocity 8. They have given that time taken by the P wave is 3 minutes less than P. P arrives 3 minutes less than S. P wave arrives 3 minutes before S. It means time of P wave should be 3 minutes less than S wave. But this velocity is in kilometers per second. Then we have to convert time to seconds. Therefore, this t time should be a time in seconds, and this one also should be a time in seconds. Then we can get 3 minutes means 3 into 60, 180 seconds. Then we can substitute 180 seconds. T minus 180 seconds is the time for P wave. Then we can get it as the second equation. Now we can simplify to find the value of x. Then x equals 8 into 80 minus 8 into 18, 8 into 0, 8 into 180, 8 into 0, 0, 8 into 8, 64, 6 remaining, 8 into 1, 8 plus 6, 14, 1440. Now we can substitute 40 is equal to the value of x. Then 80 means 2 times x. Then I will substitute 2x for the 80 value minus 1440. Now we can find the x value by using this equation. X equals 1440 kilometers. We have substitute speed in kilometers per second. Therefore, answer should be in kilometers. Then fourth one is the correct answer. So an oscilloscope is connected to a microphone which receives simultaneously a 50 Hz signal and another signal of frequency f. They have given that f is greater than 50. The figure A shows the trace with 50 Hz signal along, while the figure B shows the trace due to the combined signal. The wave of f is, the value of f is, f means frequency of wave B. In first part, they have given a wave like this. It means pure wave of source A. And in second part, they have given that a wave like this. We know that when considering two waves in the same medium, we can observe beats. For sound waves, we can hear beats. Then we can get beats frequency by using this resultant wave. It means we can consider a wave part like this in the given figure. There are two maximum points. It means full wavelength for the beats frequency is equal to the 5 full waves of given A wave. Then we can get, we know that frequency of this A wave is 50 Hz. Then we can use for the A wave, frequency is 1 over period. Then period equals 1 over frequency. 1 over frequency is 50 Hz for the A wave. Then the time taken for the 5 complete waves of A wave should be equal to the period of the second wave. Second wave means beat frequency. Then we can get for the beats period is 5 times period of A wave. It means 1 over 10. Then we know that frequency is 1 over period. Therefore, we can get beats frequency 10 Hz. Beats frequency 10 Hz. Now, we know that if there are two waves in a medium, we can observe beats. Beats frequency should be equal to the difference of frequencies of two waves. Beats frequency, difference of frequencies of two waves. Then, for the second wave, wave B, for the second wave, they have given with frequency f. Frequency should be greater than 10 or less than 10 when comparing with A wave. But they have given f is greater than 50 Hz. Therefore, we can consider that frequency of second wave, it has not grown. Therefore, we can get it if the beats frequency 10 Hz, difference of two frequencies should be 10. Now they have given frequency for the A wave is 50 and frequency for the second wave is greater than 50. Therefore, frequency of second wave should be 60 Hz. Then we can get this value is 60, this value is 50. 50 is given in the question and they have given that frequency of second wave should be a greater value than first frequency. We know that beats frequency is 10 Hz, then difference of these frequencies should be 10. Then F1 value is 60 hertz, it means answer is 3 for the student vibrated the tuning fork and listen to the to its sound while keep it in air. Then he vibrated this tuning fork again and again with same amplitude and listen to the sound while placing the handle against a large wooden block. They have given statements. We have to select correct statements. I will explain it. We know that for the first situation, tuning fork is vibrated in air. But for the second situation, it has been vibrated with same amplitude. It means same energy, but it has placed on a large wooden block like this. Now, the tuning fork is resonating with wooden block. We know that the energy of tuning fork could be transferred to the wooden block and then both objects will vibrate with same frequency. It means wooden block is resonating by the tuning fork. Therefore, there is a high energy than first situation. Then the tuning fork will be vibrated more time than first situation. Then we can get fourth answer is the correct answer. The time during which the tuning fork goes on vibrating is higher when it kept on the board than in air. A symmetric pulse shown in the figure is moving along a string towards a rigid boundary. Which of the following figure correctly shows the resultant pulse at the instant when exactly half of the pulse is reflected from the rigid boundary? Rigid boundary means it is a rough interface. Then we know that the pulse should be reflected by the rough surface and when reflecting there is a 5 phase change. It means when reflecting this pulse, it should move in opposite direction like this. But they have asked for the situation, we can see when exactly half of pulse is reflected. I will draw the situation. When this part is reflected, it is acting like this. We can draw it like this. And this part is this one. It is like this. Then we can consider this part should be in first direction because of half of pulse has been reflected. This part. Now we can consider resultant. When considering resultant, we know that according to the 5 properties of waves, there is a property interference. According to interference of two waves, we can see the resultant of these two parts in the rope. It means there is no any wave pulse we can see for this situation. Then answer should be 5 The motion of an insect living on sand generates transverse waves traveling at 50 meters per second and longitude wave traveling at 150 meters per second along the sand surface. A scorpion can estimate the location of intersect from the difference delta t in the arrival times of these waves. If delta t equals 4 into 10 to the power minus 3 seconds, the distance from the scorpion to the insect is. We can consider transverse waves and longitude waves. We can use S equal ut for both waves. I will use S equals ut for the transverse wave. We have to find distance, velocity of transverse wave 50 meters per second, and I will get time for the transverse wave is t1. Then for the longitude wave, there is the same distance because of these two distances are the distance between scorpion and insect. Therefore, there is the same distance for both waves. Speed 150, I will get time as t2. Then we know that for the transverse wave, there is a there is a low velocity. Therefore, there is a high time. There is a greater time than longitude wave. Then I will subtract T1 and T2. It is the time difference of two waves. It is given as 4 into 10 to the power minus 3. We can substitute T1 by using this equation x over 50 minus T2 by using this equation x over 150 should be equal to the given delta t value 4 into 10 to the power minus 3. Now there is an equation, we have to solve it to find the value of x. I will get x as a common factor. Then 1 over 50 minus 1 over 150 equals 4 into 10 to the power minus 3. LCM 150 divided by 50, 3 into 1, 3 minus 150 divided by 151, 1 into 1, 1. 4 into 10 to the power minus 3. X equals 4 into 10 to the power minus 3 multiplied by 150 divided by difference of these two values 3 minus 1, 2. 2 divided by 2, 1. 4 divided by 2, 2. Then x is 300 into 10 to the power minus 3. It means 0.3 meters. Then answer is 4 for the figure shows a wave pulse traveling along a string towards its end, which is connected to a small light string that can move along a vertical wire. Which of the following figures best represents the shape of the wave pulse at the instant when the peak of the pulse reaches the ring? Now they have given there is a ring at this place. It means this point can move vertically. Therefore, we can consider this end as a smooth end. For a smooth end, we can see that when reflecting wave pulse, there is no any phase change. It means this wave should be reflected in same direction. Same direction means this pulse in upward, this pulse also in upward. When the peak of the wave pulse reaches the ring, it means half of this pulse should be reflected. Then we can draw. This part is not changing. It should be like this. And this part of the reflected wave, this is the reflected part. This is the reflected part. It is not changing. Same as the reflected wave part. But this part is not reached to this stage. Therefore, it also should be same as this part, like this. Now there are two waves, then resultant should be like this. There is a high amplitude. The amplitude of the resultant wave should be greater than this initial wave. It means answer should be 2 for each of the following waves requires a physical medium for traveling. We know that there are two types of waves. Some waves are traveling without using the support of medium, but some waves are traveling with the support of medium. When considering waves which are traveling with the support of medium, the velocity of wave is increasing when the density of medium increases. But waves which are traveling without using the support of medium, velocity of wave is decreasing when the density of medium increases. They have given light waves, radio waves, sound waves, X-rays, gamma rays. When considering light waves, radio waves, X-rays and gamma rays, all of that waves are electromagnetic waves. Electromagnetic waves are moving without using the medium. But third answer, sound waves are mechanical. We know that sound wave is moving with the support of medium. Then answer is 3 for answer is 3. Which of the following propagates in the form of longitude waves? They have given laser light, X-ray, ultrasonic waves, microwave, radio waves. When considering laser light, X-rays, microwaves and radio waves, all are transverse waves because of that 4 types of waves are electromagnetic waves. We can categorize electromagnetic waves as transverse waves because of electromagnetic waves can observe polarization. But ultrasonic waves are not transverse waves. Those are longitude waves. Ultrasonic means it is a sound wave, but frequency is greater than 20 Hz. Therefore, we can't hear it by using human eye. There are 3 types of sound waves. Sound, infrasound, and ultrasound. Sound waves are in audible range. It means 20 Hz to 20,000 Hz. Infrasound, frequency of infrasound is less than 20 Hz. Ultrasound has a frequency greater than 20,000 Hz. All three types are sound waves. Sound waves are longitude. Then answer is C. Which of the following statements made regarding seismic waves is incorrect? Seismic waves means waves due to an earthquake. First statement, all seismic waves are mechanical waves and requires a medium to propagate. Yes, we know that without using a medium, seismic waves are not propagate without using a medium. Then first one is correct. Then P waves are longitude and S waves are transverse. Yes, it's also correct. You can remember points of this question as a theory. First one is correct, second one also correct. Speed of S wave is less than speed of P wave. Yes, it's also correct. Fourth one, S wave can travel through both liquids and solid media. No. P wave can travel through both liquid and solid media, but S wave can't travel through a liquid. Therefore, answer is 4 for the question.